You're listening to Bristol Data Stories. This podcast series explores the personal research journeys of our guests and the diversity of research projects they've worked on. We'll be talking about what inspires them to pursue their work, the challenges they face, and the advice they have for aspiring researchers.
Hello and welcome to Bristol Data Stories, the podcast where we talk with people using data science in research, brought to you by the Jean Golding Institute at the University of Bristol. I'm your host, Will Chapman.
And I'm his co-host, James Thomas. Today we're joined by our guest, Seth Bullock, a researcher in artificial intelligence and complex systems. He is a professor of data science and simulation in the School of Computer Science at the University of Bristol. He is also director for a national research hub into AI for collective intelligence, or AI4CI.
Hi, Seth. Welcome to the podcast.
I'm very excited to be here. Thank you very much.
Wonderful. So let's start at the beginning. What brought you to Bristol?
Well, I was born in Bristol and my family moved away when I was about 3. So it took about 40 years to get back to Bristol. And academically, the main reason for getting back here was the possibility to connect the research I do in AI and computer science with the research that happens in kind of other disciplines, biology, geography, other kinds of science. So that was something that Bristol really had on offer for me and was something I was quite excited to get stuck into.
So if we go right back to the beginning of your career, what were some of the first things that you worked on?
So when I applied for uni, there was only really 2 places in the UK that did AI. You could go to Edinburgh and be cold and far away from home, or you could go to Sussex University on the south coast and have a good time in Brighton. So I ended up at Sussex University, where they pursued AI in a very interdisciplinary sort of context. So the school that I studied in actually was called the School of Cognitive and Computing Sciences, and it had psychology and philosophy and linguistics and computer science all mixed into the same school. And at the time, I didn't realise that that was quite novel or unique, really, in the UK. I just thought that's what everyone was doing. But it meant that my first encounter with AI was very influenced by other sciences, social sciences. So when I got the chance to do a PhD, it was in Sussex University in their evolutionary robotics group. So that was a research area where computer scientists, roboticists, were taking inspiration from evolution and biology to build like small, smart little robots based on insects, for example. And I was sort of terrified when I started my PhD that they were going to hand me a soldering iron and ask me to build a robot, which would have been a disaster. But I could see that maybe there was a chance to take the kind of tools and models and algorithms that the computer scientists had and apply those back to the biology. So sort of work at that same interface, but in the opposite direction. So I got interested in simulation models of evolutionary biology, agent-based models, multi-agent systems, and got really interested in a lot of evolutionary biology. And my whole career really since then has been an attempt to be allowed to work at those kind of interdisciplinary interfaces, places where you get to talk with different kinds of scientists, places where you get to go to amazing different kinds of conference, being allowed to do that in computer science departments, where the more typical research is a little bit more focused on algorithms and technology.
And so Seth, you're on Bristol Data Stories, which is a data science podcast. And I remember when we were chatting a while ago, you said that data science is in your job title, unlike some of our guests that have sort of quite varied job titles, but you didn't think of yourself as a data scientist.
Yeah, that's right. So, I think there was a big spike of interest in data science, and lots of universities wanted to do more research in that area, wanted to do more teaching in that area. And in some ways, it's very much what I do. It's about connecting computational and mathematical sort of approaches to real world problems that people really care about, that have impact in the real world. But my research up till the point that I arrived at Bristol had not been really directly driven by data. It wasn't really about collecting data directly from the real world and applying analytics to it. It was more driven by scientific theory. So let's imagine there's some scientist, they are collecting data from the real world, and they are using that to inform their theories and ideas about the world that they're studying. Maybe they're gaining insight and developing hypotheses about say how some kind of insect species works. And what I would do is come along and build models, computational models of those theories to make sense of what those theories predict about the world, then go back to that science and do more data collection informed by those theories. So it's sort of a complementary activity, really. It's sort of alongside data science, but it provides something that the first wave of data science almost defined itself as theory-free. Right. The idea was regular science, regular statistics, regular analytics, very slow, have to take things very carefully, have to have really clear ideas and theories about what you're looking for. Why not reject all of that and just let the data inform what you do, let the data lead you. And if you have to go back and correct things, if things are wrong, that's fine, just rerun it. And so this theory-driven work, modeling, in some ways is very sympathetic and very parallel to maybe more traditional data science, but in some ways it's almost in opposition to it. They're almost like sort of warring siblings, right? One gets the upper hand for a while and then the other one has to come along and kind of slap them down and teach them a lesson.
You said you worked a lot with insects or insect models or data from observing insect colonies. Is there sort of some conclusion that you remember coming to yourself or helping someone else come to that sort of like might exemplify this side of interaction between the theory-driven and the data-driven approaches?
Yeah, that's a really good question. I've always been interested in collective behavior. So we see that in loads of different places, in a crowd of people or at a football stadium, the way the waves of, like a Mexican wave, for example, going around a football stadium is a kind of collective behavior. It's not really orchestrated by, you don't have someone standing in the middle of the football field telling everyone how to do that. It just kind of arises spontaneously, but it's a very well-defined and kind of clear sort of organizational phenomenon that you're looking at. But we also see collective behavior in much more simple systems. So colonial insects like ants or wasps or bees that live in communities often organize themselves in very sophisticated ways. And one of the things I got really interested in was how some insects build their homes. So termites, famously, some species build enormous cathedral mounds which have internal structure, and there's this kind of lovely match between function and form. So some parts of the termite mound are nurseries for young termites, and some parts are graveyards, and some parts are even farms for growing fungus. And some aspects of the termite mound do climate control and manage, humidity and temperature. And some parts are defensive walls, huge amounts of complexity there. And many of the models that were being developed to try to understand how those mounds are formed were mathematical in nature. And they, for reasons of simplicity, lacked really some important features. So, for example, you might have a math model of how termites build their mounds, which doesn't really capture the fact that termites can't move through walls, or you can't have two termites in the same place at the same time. But a computational approach, an agent-based approach, or a multi-agent systems approach, it's very easy to build in these sorts of rules. It's like a little computer game, like The Sims or something, only they're termites rather than teenagers and grown-ups. So you can take some of the observations that entomologists made of how termites initially start to build their mound, and you can take their ideas about what the mechanisms are that are governing that. So termites actually use pheromones, right, to communicate with each other, diffusing volatile chemicals that they secrete. And it was hypothesized that those pheromones were how they organize themselves and start building their termite mound. So by building a simulation, you capture those rules, capture those ideas, and show if that were really what was happening, these are the kind of structures that you will see. And you can examine those much more closely because they're in simulation, and you can observe patterns or observe features that you can then go back to the real world and test whether those patterns or features are there in the real termite behavior. And that way you can start to tell the difference between hypotheses that are consistent with the real world and hypotheses that depart from it. So there's a kind of cycle, a sort of scientific cycle there of observing the real world, collecting data, generating theoretical ideas, modeling those ideas, and then going back to the real world with targeted experiments that reveal which of the ideas make most sense.
Wonderful. I've got two questions from that. The first one is, you mentioned pheromones in their sort of as volatile organic compounds. Is it that the termites were sort of detecting the concentration of these pheromones and how that would fractionate, vertically in the colony to sort of say here build a vent and down here build a nest, that sort of thing?
So quite possibly. The disappointing kind of story here is how early we are in our understanding of termite mound construction. So the models I'm talking about, although the pictures are of these amazing, huge, elaborate structures, the models are of the very earliest stages, building a hemispherical dome over the queen termite. So the queen is actually a really horrible, long sausage-like insect. Can't move, but she just pumps out young and they do all the building for her. So one of the first things they need to do is build a kind of protective enclosure around her. And yes, the idea is the queen is giving off a kind of pheromone which creates a sort of template in the environment around her. And the builder termites are also giving off a pheromone in the cement when they chew up a pellet of soil. That fresh pellet of soil, when it's placed in the environment, gives off a pheromone. And potentially they're also using a trail pheromone that they lay on the ground as a way of organising and directing the movement of the other termites. So the interplay between these different pheromones allows them to build these sort of stereotypical structures. But absolutely, later on, if we'd got a handle on these early stages, then we want to understand the kind of gross architecture of the termite mound, and also things like, if you kick a hole in a termite mound, then the termites organise themselves to build and repair that hole. And that probably means that things like air pressure and humidity are also releasing stimuli for the termites, and it's not all down to their use of pheromones.
But so the interaction between the sort of the pheromones produced by the various members of the colony and the sort of the thermodynamics of the local area, which sort of drive these behaviours that look to us to be, and here's my second question, a sort of emergent behaviour of these sort of communities of organisms. And it's sort of, I think maybe our audience might have heard of the term emergence before. Is that the thing we're talking about, or is it something slightly different?
No, that's exactly it. So the kind of heart, the intellectual heart of understanding collective behaviour, understanding collective systems, is exactly this notion of emergence. That we can think about, whenever we think about these collective systems, if it's a collection of ants or it's a collection of people or whatever, there's one level of description of the individual parts. So one Arsenal supporter at the football match, or one termite trying to find some place to build. That's the low level of description. And then at the higher level, you've got the whole colony of termites operating as a kind of entity, or you've got the whole North Bank of football supporters, joining in on the same chant. The term emergence is often used as a kind of placeholder for the mystery of how the low-level interactions can give rise to these higher-level organisations, despite the fact that no individual is kind of orchestrating or fully in control of the collective. I think in some European football matches, you do see this like one guy right down the front who is conducting everybody, right, singing the same chant. But you don't need that. British football matches spontaneously kind of start to coordinate and sing the same chants, or this Mexican wave idea that I described earlier. So how does that happen? There's clearly some sort of feedbacks, some sort of ramification that happens. Some small thing starts, but it gets amplified and gets locked in, and then that becomes a kind of recognizable high-level feature of the system. So emergence is really a kind of term that has been used to describe the challenge of making sense of that cross-level explanation.
Wonderful, thank you. I think that probably does kind of smoothly bring us into the AI for Collective Intelligence hub. And so in terms of how do you define the term collective intelligence, relating that to previous work and to how your own directions for this hub going forwards?
Yeah, that's a really good question. So collective intelligence, I think, is a phrase that probably people have been using for a while as a kind of object of research inquiry, but it does seem to have been on the rise in the last couple of years. There's a new journal of collective intelligence that launched 2 years ago. There's a conference on collective intelligence, which is kind of rapidly growing. And I think it's unique focus has been on human organization. So how do groups of people, by communicating and by cooperating, how do they achieve kind of group outcomes that are better than the outcomes that maybe an individual could achieve? So the kind of canonical poster child type example is a kind of wisdom of the crowds type example, right? So you imagine that you've gone to a fair and there's a competition or there's a stand where there's a huge jar full of Smarties or something, and you have to guess how many Smarties there are in the jar. And everybody has a guess, and it's quite hard, and lots of people are not very good at guessing how many Smarties there are in the jar. But at the end of the day, if you take the average of all of those guesses, that's often, if the system is right, that's a very accurate estimate of the answer. So in some sense, there's a distributed kind of intelligence in the group of people that are coming to the circus. They're not all individually good at solving that problem, but as a collective, if you combine their judgments or insights in the right way, you can get a really good outcome. And although that has been studied in animals, right, swarms and shoals of fish or colonies of monkeys, all of those animal systems are also exhibiting this kind of collective behavior. There's been this focused effort on trying to understand how people can achieve good outcomes, because if we could make sense of that, then we could maybe achieve much more progress on decision making around things like climate change, around things like sustainability, around things like response to crises like pandemics, where we need to achieve collective action, and we need to achieve that in a kind of robust way, in a rapid way. So the hub, which launched this year, is one of 9 national AI research hubs that were all funded by the National Funding Agency, the UKRI. They each have a different kind of specific topic that they're interested in, and ours is interested in combining AI with this topic of collective intelligence. So historically, I guess the most kind of well-known examples of collective intelligence at scale would be things like elections or things like markets. So everyone comes together, lots of people have different ideas or different objectives or different information, and you have a mechanism like a market or an election to make sense of that and arrive at some kind of central outcome. Either you elect a person or you maybe agree on a price for something. But with the advent of the internet, there are now lots of other models for exploiting collective intelligence at scale that are not like elections and markets. So you have things like citizen science, where you have a web platform and regular people can go and log in and contribute to some kind of scientific enterprise, right? So you can be shown an image of the sky, and your job is to spot whether there's an interesting light or pattern in that image. And it would take scientists a very long time to process, to view all of the images that they have to look at. But if you decentralize that across the entire population of people that are interested in astronomy, then you can achieve, rapid progress by combining the collective effort of all of these people.
Not everybody taking part of that has to be correct. They just have to have enough people having a go, even at a non-expert level.
Exactly, if you structure it right. So, for example, if you just had, let's say we're not looking for interesting binary pulsars or whatever, let's say we're looking for melanomas or cancers. You wouldn't want to set that up in a way where you decentralize that judgment across a population, and whenever one person thinks they have seen one cancer, you immediately get that person in and cut them open. You would need some sort of redundancy, some sort of robustness, some sort of clever way of combining multiple judgments, some sort of triage or some sort of first pass that alerts experts to put their attention into the right part of the data. So you don't get necessarily great collective intelligence outcomes for free. And the research in this area is all about how can we design systems where we get really good outcomes, good collective intelligence outcomes, and not some pathological outcome like groupthink or like maybe outcomes that are very dominated by overrepresented kinds of people. So maybe how do you make sure that marginal voices or underrepresented people in your collective are getting their fair crack of the whip?
And I guess this is a phenomenon we've seen in social media recently around elections and other issues, is that the group collective intelligence does not always lead itself to the best answer.
Exactly. So the research field, I think, is as much interested in the kind of positive thesis of collective intelligence could be hugely useful. Let's operationalize it. Let's mobilize it in order to solve problems. And the flip side of that, which is when it is pathological, when it is malformed, when it doesn't work, collective intelligence happening naturally in the real world could lead to terrible outcomes. It can retard progress. It can prevent us from solving problems. It can distort the allocation of resources. So both sides of that, I think, are interesting research questions for psychologists, economists, decision theorists. The AI for Collective Intelligence Hub is about how can we introduce AI judiciously into these kind of collective systems in ways that improve people's quality of life, and to what extent could we ensure that those systems are robust and that those outcomes are kind of reliable and repeatable.
So in a way, the collective intelligence is already happening. It's about ensuring that, AI-based tools we might use to help that collective intelligence happen aren't going to work to the opposite.
Exactly. So in a setting like diabetes, for example, you've got a lot of people across the country managing diabetes in different ways because their circumstances are very different. And in a limited sense, people are able to kind of share advice and information with other people with diabetes, but it's a relatively private and personal matter. And the extent to which we're pooling our expertise in how to cope with diabetes, that's probably relatively limited, which would be okay if every diabetes patient had a lot of opportunity to talk with experienced clinicians who also have a lot of expertise. But because of resource limits, you probably don't get a huge amount of time with a clinician to talk about exactly how your diabetes is changing and how your life is changing and how to improve the way that you're coping with your diabetes. So we often end up in a kind of one size fits all or a relatively small number of sizes fit most sort of solution. But given that we do have thousands, tens of thousands, maybe hundreds of thousands of people who are all problem solving around the issue of diabetes, if we could find some way to pool that knowledge, if we could find some way to combine that knowledge in a way that preserves people's privacy, in a way that people feel comfortable engaging with, there's this potential upside of informing each person with diabetes of ways that they might improve the way that they're managing their condition. And that's just one setting. You could imagine something similar happening around financial decision making, that everybody is also doing that relatively privately. Decision making that is happening in city planning, where there's a lot of people making plans independently from one another, and we could achieve maybe more sustainable cities if that planning was somehow joined up. So it's all about, I think one way of thinking about this is moving away from an image of AI as being a one-on-one conversation. So I will fire up my AI and I will ask it to help me solve a problem. I would like a picture of a dog riding a skateboard. Here, Seth, here are some pictures of dogs riding skateboard. It's a kind of one-to-one dialogue. Moving away from that to an idea of AI mediating and improving dialogues amongst a whole collective of people. So AI operating at a collective scale rather than a sort of monolithic one-to-one conversational mode.
So Seth, can you tell us a bit about what the motivation for this hub was?
When you're thinking about how to win a big grant, there's a bunch of different things that have to come together, and it's not always completely driven by what your academic interest is, because it has to be something that taxpayers' money can be spent on. So for me, the kind of interesting tension in this idea of collective intelligence, you start with a lot of people with different opinions, and most collective intelligence settings are about reaching one central final outcome. And so there's obviously a lot of risk there that the diversity that you have at the start is collapsed down into one outcome, and potentially you might systematically disadvantage repeatedly the same people. They're always the people whose opinion doesn't end up being, winning through this process of compression. And AI in general faces this problem, right? That AI is about basically, or machine learning. It's about compressing data into a compact model that you can then interrogate, right? Put an interface on it. And so fringe data, peripheral data, marginal data, that's what ends up possibly being lost in this compression. And in human systems, those are people, those are marginalized people, fringe people, underrepresented people. So if you want AI systems at national scale, and what the AI Hub was aiming for was pursuing research on how AI systems could be used in the UK at national scale, you want to understand the winners and losers that those AI systems might create, and you want to minimize the extent to which you damage the interests of marginal people. So there was this strong close the AI divide sort of motivation. So about 10, 20 years ago, 15 years ago, there was a lot of talk about the digital divide. People without smartphones, people without broadband were going to be left behind because they couldn't access services, they couldn't take advantage of modern facilities. And now you might talk about an equivalent AI divide, that there are people in society who are not going to benefit from AI because they're not rich people running companies, they're not tech-savvy people who have access to AI, they are being left behind. And those are the people that are likely to be disadvantaged if AI is deployed at national scale to do things like help people with finance or help people with their healthcare. So there was a sort of strong motivation to engage with that. And that meant the Hub has these kind of 5 application-driven themes, which I've mentioned. So healthcare, smart cities, finance, pandemics, and the environment. In each of those domains, we need AI to help coordinate and communicate and improve people's quality of lives. But there are 2 cross-cutting themes as well. One in human-centered design. How can you, if you have ambitions to make national-scale AI systems, how can you make them usable? How do you make people comfortable using them? How do you create systems that are worthy of being trusted? And how can you ensure that they remain fit for purpose over time as their users change and the data that drives them changes? And the final theme, the 7th one, is also a cross-cutting theme on infrastructure and governance. If you're going to operate at national scale, and we now have a AI supercomputer for the nation, Isambard AI, which is based, it's hosted at Bristol, and that was a big influence on our bid. Now that we have a supercomputer that we could, it's sovereign, it's owned by the country, we could put people's healthcare data in that facility without exposing it to Microsoft or Google. So with that infrastructure come questions of governance. How do you run large-scale AI systems in ways that are not going to be vulnerable to scandals? So just coming through the revelations of the Horizon scandal that affected the UK post office system, where a piece of software went wrong and damaged the livelihoods and lives of a large number of postmasters. And that was probably the most boring piece of software that you could imagine. Some payroll software, some database management software. The kind of AI systems that we're talking about are way more complex than that. And so in 10 years and 20 years' time, we have to think about avoiding the kind of scandals that we're currently seeing in the post office that might arise as a result of using AI and machine learning in ways that we don't understand.
Creating not just the software, but the sort of the human infrastructure around this software and how we implement it, how we design it, how we use it. It doesn't sound like that's just a computer science problem. Can you talk about the sort of expertise that you're wanting to develop at this hub, and where you see drawing people from?
Yeah, definitely. I mean, and I think this is one of the most exciting aspects, because it means the kind of challenge that I'm interested in can't really be addressed just by computer scientists. And that means we get to work with a really interesting bunch of varied people. So the expertise that we need here involves domain expertise. So people that really know about pandemics, people that really know about finance. And it requires these kind of generic expertise in basically people. So psychology, sociology, law, ethics, management, design, and really interesting questions across all of those disciplines that can only be answered kind of jointly. So
you might say collectively.
Yes, you might say collectively, although we try, I mean, it's a constant fight against making jokes about collective intelligence or stupidity in every meeting that we have. So the challenge there is in bringing in people who have diverse skills but can work together, and that kind of skill, that kind of ability to operate in an interdisciplinary mode is extremely valuable. And I think probably AI is going to be an area, and data science, I think, are going to be areas that really place a premium on that, on appetite for interdisciplinarity. Not everyone really wants to work with a team of people that are all different from them. So I think that appetite for it and ability to do it, which I think requires skills that are not necessarily taught as a kind of canonical part of a science degree. I think that's what is going to make AI work and give us the kind of progress that we're going to need.
So we've talked about the challenges that you face in terms of the model and then compressing information down to this kind of median individual, and how do you cope with that? Can you give us a sense of some of the other kind of socio-technical challenges as well that the field faces?
Right. Okay. So that's really interesting. So there's a sort of mix of technical and socio-technical challenges that cut across these different collective intelligence settings. So there are questions around privacy. So you're collecting data from lots of different people. In many of these settings, it's sensitive data, health data or finance data, and you need to combine it in order to find the patterns and trends that are going to inform your model. But you need to do that in ways that preserve the privacy of the individuals that gave you their data. So federated machine learning and privacy preserving machine learning are really interesting fields that are going to be relevant here. And then a different angle is to do with anomaly detection, change point detection. So unlike a lot of machine learning challenges, the systems that we're talking about are not stationary. So the population of people with diabetes is changing, or the way that people access or what they require from financial services is not a fixed target. So training a system in a kind of fire and forget way is not going to work. You have to continuously evolve your model, and you have to understand when the world is just changing smoothly and when the world is going through some kind of regime shift where you have to reconstitute the model entirely.
How do you think that changes how we approach healthcare?
Well, I think it changes it in an interesting way, which has already been sort of anticipated by the NHS. In 2019, they published something called the NHS Long-Term Plan, and running through it is a sort of shift from the accent on managing acute care, waiting lists, on pivoting away from that towards managing the health of the entire population within an NHS trust. So managing health and helping to steer people in ways that maintain their health and avoid them placing a load on the NHS. So implicit in that document is a sense that it's technology that is going to enable that to happen, right? That kind of mass management, assisting people in their lifestyle and in their health care and disease prevention. We don't have the resources to do that manually. We're going to require automation and technology to do it. And the document doesn't really spell out how we get that technology or what it looks like. But the AI for CI Hub, one aspect of it is exploring one approach to delivering the kind of technology that changes the way the NHS cares for the health of people in the UK.
And I guess we've looked at that as a specific example that's in healthcare, but the hub has these 5 different domain areas that it's looking at, and those other cross-cutting themes. So I guess it's that, but applied to all of these.
Exactly, yeah.
So zooming out and thinking back again about data science, how do you think that's allowed you to develop your career?
Well, I think it has given me opportunities to apply computer science and connect kind of quite interesting blue sky type ideas, like the conversation we were having earlier about football stadia and about termites. It creates a bridge from those kind of conceptual ideas, emergence and self-organization, to really important real-world challenges that funders are willing to put money into and that journals are willing to publish and that researchers want to come and work on. So I think it's an enabler of some really, really interesting research. I mean, I think maybe a lot of data science does tend to end up quite at the kind of pointy end of getting things done, right? It's very close to real interventions, real decisions that are made in the real world. It styles itself in a very practical, no-nonsense sort of way. I think data science often doesn't have much time for high-minded ideas and deep concepts and stuff, but I really see a connection between those things, and I think the kind of way that data science foregrounds the real world and the real world impact of computer science keeps whatever you do legitimate and relevant to regular people.
And how easy is it to become an expert in data science and stay an expert in data science?
Well, that's a really interesting way of framing it, because I think they're two very different questions. So, I mean, in some sense, until recently, maybe becoming an expert in data science was pretty easy. I mean, it sort of happened by accident to me. I didn't really even try. But maintaining some expertise in data science, I think, is probably one of the hidden challenges, right? That it's a field that is evolving extremely fast and changing very quickly. And keeping on top of things and being confident enough to operate as a data scientist against a continuously changing backdrop, I think is very challenging. And there is a risk in the data science community of burnout, and I think things like imposter syndrome, issues where people are struggling to keep up with the range, the breadth and the dynamism of the kind of tools and systems that you're expected to be on top of. So, it's a double-edged sword. On the one hand, it's really interesting because it's so dynamic and it's evolving so fast and there's so much variety. And on the other side, the other edge of that sword, it is a struggle to gain a sense of confidence that you're on top of all of the tools and systems that you're expected to.
So it can be a bit overwhelming. But that's part of the interest, and it's okay to feel like that.
I think so. And I don't think it's alone. I think a lot of computer science is like that. It's a very, very young field, and I think we forget how young it is. Most universities didn't have computer science departments before the 80s, whereas if we were talking about physics, I would have to tell you which century I'm talking about, right? So it's very new, and it's changed very quickly, and computer science has had such a huge impact on the world that has created this kind of maelstrom of different research questions and techniques. And I think that permeates all of computer science, really.
So that, I think, brings us nicely to our sort of final quick-fire questions. Before you go, we'd like to ask, what is your top piece of advice for anyone looking to get into your field?
Well, I think the most undervalued thing, I think, is talking to people. I think developing listening skills, the ability to talk to people about what they're doing, what they want, what's important to them. If you want to be an applied scientist, an applied engineer, it doesn't matter whether it's data science or anything else, you need to be authentically listening to people, because you need to build things that really address what they want. And that's not as easy as it sounds, because often people don't know what they need to say to you. They don't know what they want. And so there's quite an interesting back and forth to sort of be able to get that out. And, there's a sense in which I think a lot of people get into the information sciences, computer science, not necessarily because they're really into listening and talking to people. So I think combining those things, technical skill and the ability to listen and talk to people is really useful.
And if any of our listeners want to find out more about your research and the AI Collective Intelligence Hub, where should they look?
So we have a webpage, ai4ci.ac.uk, and you can find everything there, including job opportunities, PhD opportunities, and increasingly we're going to be putting information there about the research that is taking place.
And if they want to find more about termite pheromones?
That's a bit harder. If you go to a library and you go to the shelf of books about termites, about 90% of them are about how to kill the termites, and only a small number are about how amazing they are. But if you look up the work of a researcher called Eric Bonobo, he was a big inspiration for me and is a source of a lot of really interesting models of how termites and other social insects work.
Wonderful. That went off a bit off script a little bit. We'll share links to the things that you mentioned and the AI for Collective Intelligence Hub in the description. And finally, thank you, Seth Bullock, for telling us your data story.
Thank you very much.
Thank you to our listeners for tuning in. If you have any ideas for guests you'd like to hear from or topics we should discuss, we'd love to hear from you. You'll find contact details and a link to join our newsletter in the description.
Your hosts today were Will Chapman and James Thomas. Your producer was Kerry Turksey, and the Bristol Data Stories was brought to you by the Jean Golding Institute at the University of Bristol.